We'll then try to understand the various operators that are supported by C language. Operator, as we know, is a special symbol that tells our compiler to perform some mathematical or logical or bitwise operations. So what exactly we mean by all this? So we know, as we have discussed in the previous example, something like relational and logical operators. We'll try to discuss all the different operators that are supported by C language, starting with arithmetic operators. So we have something called arithmetic operators, which basically helps us to perform arithmetic operations. We have relational operators, as we have seen in the previous video, which are normally used in order to compare the values. Then we have logical operators, which are used to join multiple conditions. We have bitwise operators. These are something new for us. We'll try to understand this, followed by assignment operators, and then we have something called ternary or conditional operators. So these are the various types of operators that are supported by C language. We'll go one by one. We know arithmetic operators, when we say, it means you can perform addition, you can perform subtraction with the help of this operator, you can perform multiplication with the help of this, you can perform division with the help of this, and then you can check for the remainder after division with the help of this percent symbol. Otherwise, you can also call it as modulo and so on. So, for example, let's try to understand this. We know all this. If the value of A happens to be 200 and value of B, say, is 100. So A plus B, we know the value is going to be 300. A minus B is 100. A into B is 20,000. A by B is 2. A percent B. So when you divide 200 by 100, what is the remainder we get there? The quotient will be 2, but the remainder is going to be 0. So that is how you can make use of this particular operator. And all these operators, we call them as arithmetic operators. Then we have relational operators, wherein you have greater than, less than, greater than equal to, less than equal to, and this is equal to, normally used to do the comparison, followed by not equal to. Example, you can say if value of A is 200, value of B is 100, A greater than B. You can make use of these symbols in this fashion. A greater than B, true? Yes, because the value is greater. A less than B, false. A greater than or equal to B, it is again true because it is greater. Greater than or equal to. So either of this you will make use of. And then A less than or equal to B, false, because A is neither less nor equal to this. A equals to B, false, because they are not equal. A not equals to B, A not equals to B, here I have written it as false. Is it true or false? A is not equal to B, so it has to be true and not false over here. So we need to make a correction over here. It is not false, it is true value. Similarly, we have logical operators. Logical operators, we mean we can make use of AND operator by using two ampersands. We can use pipe symbol to say OR, and then exclamation to say NOT. So how do you make use of this? So you can say A equals to 10, B equals to 20, C equals to 15. If the values happens to be like this, then you can say A greater than B, true or false? This is false because A value is 10. And A greater than C. So when you say and, we know it has to satisfy both the conditions. So then the result is going to be true, otherwise it is going to be false. So in our case, the first condition is false. So irrespective of the status of the second, it is going to be false. In the similar way, A greater than B is false, but you are using an OR operator. So B greater than C, B is greater than C, true. So the result of this is going to be true because you satisfy one condition out of these conditions that are given. And then A greater than B, A greater than B is true or false? A is greater than B, false, but not of false is going to be true. So this is how you can make use of logical operators. Similarly, you have an operator called ternary operator. Ternary operator can be used much similar to that of your if and else statement, but you can write it in this fashion. It is much more simpler to write, and the syntax is going to be different than if and else statement. So what is that you are going to do here? You are going to specify the condition over here, and then you will write a question mark followed by statement 1 colon, you will write statement 2. What it means for us, if the condition over here that you specify, if it is true, then statement 1 is going to get executed. If it is false, if the condition happens to be false, then it will execute statement 2. So let's go with an example. A is 100, B is 200. A greater than B. So we know A is not greater than B. So it is false. False means it will execute second statement. So the result is going to be equal to B. So that is how you can make use of ternary operator. So this can be used instead of we making use of if else statement. Similarly, you have something called assignment operators. Assignment operators are like plus equals to, minus equals to, star equals to, slash equals to, percent equals to, and single equal to. Which means what? Take an example. If A value equals to 200, B value equals to 100, A plus equals to B, it is as good as we writing A equal to A plus B. So instead of we saying A equals to A plus B, you can as well write A plus equals to B. Similarly, A equal to A star B, you can write it as A star equals to B. Similarly, A equal to A percent B, you can write it as A percent equals to B. Similarly, A equal to A minus B, you can write it as A minus equals to B. And then A equal to A by B can be written as A by equals to B. So this is the other way of rewriting this particular statement. Then we'll try to understand bitwise operators. So bitwise operators basically are going to work on bits of data. Bits over here means whenever we store the data in our system, we know that system stores the data in the form of zeros and ones. So 0 or 1, we are going to call it as a bit. Bunch of these bits, 8 in number, you call it as byte, and so on. So as we know, in case of your decimal numbers, we go by units place, tens place, hundreds place, and so on. In the similar way, in case of binary numbers, you are supposed to go with 2 to the power 0, 2 to the power 1, 2, 3, 4, so on in this fashion. So what are the bitwise operators that we have over here? We have ampersand. You need to write it as only single ampersand. That is AND, OR. This is for XOR. What exactly we mean by this? We'll try to understand. This is a tilde symbol over here, which is complement, we say. Okay, and then this is for left shift, and this is for right shift, and so on. So let's try to first understand how do we write binary numbers. So binary numbers can be written in the form of 2 to the power 0, 2 to the power 1, 2 to the power 2, so on, so on. So that means 2 to the power 0 is 1, 2 to the power 1 is 2, 4, 8, 16, 32, 64, 128, 256. So likewise, you can continue further. So if at all I want to write 10 in binary, so 10 in decimal, I can write in binary in this fashion. 10 means I have to combine 2 and 8. So that means this fourth digit is going to be 1, and then second digit is going to be 1. Rest all I am going to write it as 0, which means what? This is to indicate 8 and this is to indicate 2. So that means this value happens to be 10. In the similar way, 100. So when you say 100, you have to make use of 64. So these two will be 0 because you don't need this. 64, you can take it as 1. Plus 32 is going to be 96, then you require only 4. So this is 0, this is 0. And then here you will write 1 and rest all will be 0. So that is how you represent 100 in binary form. Now in order to work on these zeros and ones, you need to make use of bitwise operators. So let's understand these operations. Example, you can take 60. How do you write 60 again? 60 will be written as 32 plus 16, that is 48. 48, and then you will write it as plus 6, that is 56, and 4. So how you are going to write it? These two 0 and then 1 1 1 1 0 0 1 1 4 times, and rest all can be 0 over there. This is 60. And then 13 means you will write it as 1 1 and then 0 1 1 1 0 1, and rest all can be 0. So just an example I have taken over here, where the value of A is 60 and the value of B is 13. Now what is that you do? You perform A and B. So how you are going to say? You are going to go with an operation called ampersand. So ampersand means you will try to perform AND operation over there. So internally in our system, AND, OR, NOT, these are all logical gates. So sometimes later we'll see what are the various logical gates available and so on. So when I say ampersand, the result of this is going to be true when the value is going to be 1 in both the cases. That is, if A value is 1 and B value is 1, then only the result is going to be 1. Otherwise, it is going to be 0. So in our case, let's try to do this. So 0, 1, your result is going to be, when you say AND operation, it is going to be 0. Both zeros, definitely 0. 1 and 1, your output is going to be 1. 1 and 1, your output is going to be 1. Here again you have 1 and 0, so 0, 1 and 0, so 0, and so on like. So this is how you can perform A ampersand B, and the result is 1 1 0 0. So if you write 1 1 0 0, it means the result is going to be 12, and so on. So this is how you can perform AND operation using bitwise operators. We'll then try to understand bitwise operator called complement operator. So how we are going to make use of this? If A value happens to be 1010, which is nothing but 10, then in that case, complement of this is going to be zeros are to be converted into ones and ones are to be converted into zeros. So this 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0. So this is how you are going to perform ones complement of a given number. Then lastly, we have two other operators called left shift and right shift operators. So if the value of A happens to be something like this, then left shift operator over here means we are going to shift the numbers towards left side. So in that case, what happens is when you shift these numbers toward the left side, so then these two zeros will, that means you are going to shift from here to the left side, this number to the left side, so on, so on. So when you shift it for two number of times, this 0 will disappear, this 0 will disappear, and you will left over with 1 1 1 1 0 0, and then two more digits will be added over here towards the right side of the number. So that is how you can perform left shift operation. In the similar way, if it is right shift operation, A greater than 2 if you write, it means these numbers will be shifted onto the right side. So these two digits over here will disappear, and then you will get the result as 4 zeros at the beginning, because two more will be added, and then followed by 4 ones, and so on. So this is how you can make use of left shift and right shift operators, which are called bitwise operators. So what are the various bitwise operators we have? And, or, not, you can call it as caret over here is to say exclusive or, and not. And then you have ones complement, left shift, right shift, and so on. So then we'll try to go with a new concept of learning a statement called a switch statement. So the question that arises is, what is switch statement and why to make use of this particular statement? Switch statement can be used in order to check multiple values, and based on a value, you can display or perform some action. It is much similar to that of your if and else statement. So how the syntax of switch statement is going to be? You will say switch, you can write over here some expression followed by, you can write here a case statement, case, and then you can write some constant expression over here. That means you can put a variable over here, and if the value of this variable happens to be, say, 1, then you can write over here case 1, and then you need to write a colon. Then you can have a statement or multiple statements followed by break. So what happens if the expression is satisfied by the first case, then it will execute this statement, and then your switch case statement terminates. Otherwise, it will go to the next case statement, otherwise to the next case, and so on. So you can have n number of case statement, and then lastly you can write a case statement called lastly you can write a default statement over there, default statement, which means what? If the expression value matches with the first case, it will go here, otherwise with the second, otherwise with the third, and so on. If it is not going to match with any of these expressions over here which are written in case, then it is going to perform the statements which are displayed in default, and so on. So let's try to perform an exercise on this. Then you will clearly understand how to make use of, when to make use of this particular statement called switch case statement. Go by an example. Raj wants to find out the day of the year 2020 by giving the number as, so if I am going to give the number as 1, I want to display the day as Wednesday. If it is going to be the number going to be 50, the day has to be Wednesday. If it is 100, it has to display the day as Thursday accordingly. So how is that you are going to perform this? So what is that you want to do here? You want to accept a number, and then that particular number you want to convert it to day of the week. So we know there are 7 days in a week. So given number, you divide by 7 and check for the remainder, and based on the remainder you can say if it is 1 as the remainder, then you say it is Wednesday. If it is 2 as the remainder, then you say it is Thursday. If it is 3 as the remainder, Friday, and so on. So how is that we are going to write this? What is that you need over here? You just need to accept a number. So you can take number as integer, and then you can accept this value from the user. You can say to the user, enter a number to display the day, to display the day of the week. You can say day of week, and put a semicolon over there. Yeah, and then you can accept the number by saying scanf %d ampersand. You can say NUM. Now, what is it you want to do? Based on this number, you want to display the day of the week. So what do you need to do? You need to write a switch statement, and you need to switch as per the value that is given by the user for a variable called NUM. So switch to num case, you will write it as 1. That means what? If the number is 1, better I start with 0. If the number is 0, you can display it as printf day is Tuesday. Okay. In the similar way, if the number is going to be 1, then you need to say printf the day is Wednesday. Similarly, if it is not 3, if it is 2, then you will say it is Thursday. Similarly, if it is going to be 3, then you will say, you need to type a lot here. You need to say Friday. If the value of case is 4, then you will say printf Saturday. If it is going to be 5, then you will say printf Sunday. If it is going to be 6, then you say printf Monday. You can as well write default. So when it comes to default, whenever the number that you have given, is not 0 to 6, then it will come to default. So in my case, what I will do is the number that is given by the user, in order to make this or in order to display the day of the week, what I have to do is I have to divide that number by 7, and then I have to check the reminder for that. So when I divide by 7 and then when I check the reminder, my reminder can be 0, it can be 1, 2, 3, 4, 5, 6. So there is no question of I writing default over here. And as we have seen, in every case statement, you are supposed to write a break statement. Otherwise, what happens? It will continue for the next case statement and so on. So you need to write break after every case, something like this. Yeah, now you can see. So what is that we are trying to do over here? Suppose say the number that you have given is 1. So then what happens? 1% 7, the remainder is going to be 1. So if it is 1, we need to display it as Wednesday, as it is given in our problem statement. Otherwise, if it is 2, display it as Thursday and so on. So then you can run the program there and then you can give the value to display the day of the week. If it is 1, you will get it as Wednesday. If it is, say, as per the problem statement, if it is 10, it is going to display you as Friday. Then it is 50 and 100 we need to check. So you can check here. If it is 50, what is that you get? Wednesday. That's right. What is asked in the program. And then if it is going to be 100, then it has to display it as Thursday. So that is what is asked to us in a problem statement, and we are able to do that. So what is it we are trying to understand here is when a number is given by the user, we know user can give any number within the limits of your integer value. So then what happens, that number, in order to convert it to day of week, you need to divide that number by 7 and you need to check for the remainder. So any number that is given, you will convert it to weekdays. So it can be 0 to 6. 0 can be the remainder and the maximum remainder you can have is 6 and so on. So accordingly, you can display the day of the week. So this is how you make use of switch case statement. So you will say switch to that number. So depending on the value of this number, if the number happens to be 0, it will come to case 0, it will execute this, and because of break, it will go to the end of the switch. If it is 1, it will go here. If it is 2, it will go here, so on up to 6, and your number cannot be anything apart from this, except otherwise you give a negative number over there. If I give -3, then it is not going to display me any value. So now what I can do is I can add over here a default statement. So in default, I will just say printf. What is that I should enter now? Enter, I'll give a message to the user, enter positive numbers only. So the user is not supposed to enter any negative number over there. So if the user enters any negative number, like say -100, it will then come to default statement. If it is other than that, any other number, then it is going to display a day of the week. So that is how you can make use of switch case statement. So with this, I will end this particular video, and then we'll see how to make use of looping statements in C language in my next video. Thank you. If you like all the program that we are doing and the way I'm teaching, please subscribe to my channel and try to share them among your friends. Thank you once again.